Hello everybody, this presentation is on sketching graphs of the form y equals e to the x, and we'll discuss the number e in just a moment, and it's mainly related to the exercise in your textbook 5e. Now e is a very interesting number. It turns up in a lot of different applications of mathematics and other, I guess, more practical applications. It turns up in finance. It was discovered by a mathematician called Leonhard Euler. Euler was Swiss, and he was one of the most famous mathematicians in history. He wrote many textbooks, well over 200 textbooks at different levels of mathematics. Worked within a number of different branches of mathematics rather than specializing. He was able to be more broad and be world-leading researcher in mathematics in a number of different areas. And what he discovered was that he was experimenting with a series one day, and he was sort of saying, well, if I have 1 plus 1 half squared, I'll get 9 to the 4. If I have 1 plus 1/3 cubed, I'll get 64 over 27. And what he found is that these were moving towards a particular number. So he said, what about if I do something along the lines of I'll make a limit and I'll make n approach infinity, and if I go 1 plus 1 over n to the n, and that approached towards a number 2.71828, and the number kept going. And he thought this was very interesting, so he called the number e, and he said 1 is equal to this particular sequence here. And that's how we came up with the number e, which is, as I said, about this, and the number keeps going after that. It's an irrational number, so we can't find a nice fractional approximation to this number. It's just a number that keeps on going like a square root. Now, what happened? Give me a second and I'll give you a problem to sketch. Alrighty, now what happens if we have to sketch this graph here? Now let's see. The asymptote will be at 2, and I might rewrite this graph so it's a little bit easier to interpret. I'll put a +2 there, which means the asymptote is moved up 2. So the asymptote is at y equals 2. And with this negative here, it means that it's flipped over underneath. So instead of going up like this, it'll go down like this. So let's see here, it'll have a y-intercept and an x-intercept. So let's see, x-intercept, y is equal to 0. So that'll be 0 is equal to -3 to the x plus 2. That'll be 3 e to the x. And then we'll go e to the x is equal to 2/3. And we'll use a logarithm here, so log e will be equal to 2/3. Now since this is less than 1, I believe this will be negative. So we'll go log e 2/3 to 0. Alrighty, now what happens if we have to find the y-intercept? That'll be when x is equal to 0. So this will be 3, or -3, e to the 0 plus 2. Should be -3 plus 2, which is y will be equal to -1. So our intercept will be -0, -1. So 0 minus 1 is down there, and our other intercept, which we'll label log e 2/3 0. So our graph will come and go down there and through there and down like that. Now, our domain and range, well, let's see. The domain will be all real numbers, and the range will be from -infinity up to, but not including 2. Alrighty, let's try one more. Alright, well, what about if we translate a graph y equals e to the x? Okay, well, let's see if we can put it into some matricy form. Now we want to dilate it by 2 away from the x-axis, which means we'll be changing the y value. So if we use a matrix, now let's see, how can we change the y values? Well, the x values will stay the same, so we'll put a 1 on the leading diagonal, and on the bottom right element here, it's dilated by 2 from the x-axis. So if we multiply this by the matrice xy, this position needs to be 2. Now if it's reflected in the x-axis, the y value will be negative. Now 3 units in the x direction, that'll be 3 up there, and if we add it to the x value, it will give the x value another 3, which will move it across to the right, or in the positive x direction 3. Now 4 units in the negative y direction, negative 4 will go down there. So we could have the equation, so the new values of x will be a times the old values of x plus b. So here are the new values of x and y. Here is the new, here are the old values of x and y, subjected to the changes that we've got here and here and here and here. And since these ones come first, we'll multiply them first and then add them second, because that's the order that we'll do them. So if we work out this matrice algebra, we'll have x plus 3 and minus 2y minus 4. Now what we'll do is we'll translate these about so that the values of x and y in the new and old values will be kind of turned around. We used to have the new value of x is equal to the old value of x plus 3. We used to have the new value of y is equal to the old value of y times by minus 2 minus 4. Now if we change that about, we can change it around so that the old values are in terms of the new values. If we change this one about, we can find out that the old y values are now being turned into something in terms of the new y values. Let's go over to the page to give us a bit more room. Now we have our equation y equals e to the x. And we figured out the old y values in terms of the new y values. We figured out the old x values in terms of the new y values. So if we substitute those things in, now let's see, I'll multiply this by 2, or by negative 2, and I'll take away 4 from each side. So here is what our new graph will look like. It'll be y equals negative 2 e to the x minus 3 minus 4. The minus 4 would move everything down 4. The minus 3 would move everything across to the right. It would be reflected in the y-axis and dilated away from the x-axis by a factor of 2, just as we wanted to. Alrighty, well I hope that helps everybody, and I'll see you in class. Now don't forget, this is all related to exercise 5b, so have a go at doing a couple of those. Alrighty, see you in class.